Welcome to the webinar Get It Out of the Box. In this webinar, you will learn how Miltenyi Biotec provides inspection readiness for its MaxQuant analyzer flow cytometer family and the Titer-cell sorter upon instrument unboxing and installation. In particular, Miltenyi Biotec provides GMP customers with closed systems that ensure data integrity and electronic records compliance by instrument design. Unless otherwise specifically indicated, Miltenyi Biotec products and services are for research use only and not for therapeutic or diagnostic use. MaxQuant, the Miltenyi Biotec logo and Stan Express are registered trademarks or trademarks of Miltenyi Biotec or its affiliates in various countries worldwide. Flow cytometry is a classic method utilized for continuous and process quality control alongside the CAR T-cell or other cell therapy manufacturing procedures. Using flow cytometry data to ensure cell therapy product quality requires several considerations as parts of the risk management process. First of all, data integrity represents a major challenge to cell therapy manufacturers as the equipment is more and more computerized. Data is no longer represented by a simple printout or a value on the screen. Data is multiparametric, it's complex, it requires calculations, there are multidimensional plots to be interpreted and considered, and reprocessing to display the data result in different ways is required. Reliable data is at the same time key to guarantee that cell therapy products are safe for the patients. All the data created during product manufacturing and analysis therefore must maintain its integrity and follow the so-called Alcoa principles throughout the whole life cycle. The responsibility to assure data integrity to support cell therapy product quality lies with the manufacturing company. Cell therapy manufacturers that must conduct any work in centralized GMP facilities or decentralized point-of-care sites have to ensure that instruments utilized in the process onboard technical solutions following Alcoa principles. Alcoa principles are put in place to ensure, for example, that data and electronic records are accurate, complete, and consistent. Are these technical solutions not provided by the instrument vendor, it is required for the manufacturer to introduce such measures manually. Not having such tools on board by design delays patient treatment and increases costs by increasing time to market release of the cell therapy product. Typical flow cytometry data with impact on patient safety is cell population statistics that is often used to determine cell therapy product dosage. Product quality in flow cytometry typically relies on validated gating templates that ensure correct target cell identification. Moreover, data integrity is controlled by release of analysis reports signed by responsible subject matter experts. So what are appropriate controls to establish data quality? Examples are digital signatures of analysis reports, role-based access control that guarantees segregation of duties as required for the intended instrument use, full traceability through audit trails, as well as a kiosk mode for data acquisition and analysis to stay within the approved and validated workflow. Therefore, one of the main tasks of computer system validation engineers is to probe whether all these conditions are given prior to the use of a flow cytometer as a quality control instrument, or whether there is a need to introduce custom technical solutions. Inspection readiness of an IPC-QC instrument like a flow cytometer upon purchase and installation is not self-evident. Often, so-called open systems are delivered, meaning that your instrument has to be connected to a computer running an up-to-date Windows operating system, where you install the cytometer data acquisition software. Now, this approach comes with several challenges, the major of which is the fact that any user can access raw data, other user folders, or reports outside of the qualified and validated workflow. This is a major risk towards data integrity requirements and usually involves your local IT that must set up every computer used for data acquisition or analysis in a GMP-compliant fashion. This requires a lot of resources and delays the go-live momentum of your GMP facility or point-of-care site. As the market recognized this gap, some vendors of flow cytometry instruments are offering now commercially available 21 CFR Part 11 add-on packages. These packages contain, for example, audit trails to record user and system actions, preset user roles like admin or normal users for segregation of duty, but they still contain or rely on a Windows 10 or 11 operating system. However, from the validation point of view, one has to ask questions like, are there audit trails that I can see? Are they complete? What does complete means? Are the available preset user roles sufficient for segregation of duties? And do they also mirror my needs? And of course, is Windows made by design to ensure data integrity? Speaking of the operating system and closed open concepts for GMP instruments, there are two different approaches. The Windows top-down approach requires the customer to adapt the instrument for electronic records and data integrity compliance, usually by the local IT department. This is the most frequent concept one can find in the market. Windows is not compliance ready, but can be made compliant since it is a user interface-based OS that comes with a huge administrative toolset like global policies, user management, and provides the possibility to install third-party tools if necessary. Further down the road, the actual operating system is working in the background to connect hardware and applications. However, purchasing a flow cytometer or any other GMP instrument in a price range as big as 95, let's say 100 to 700,000 US dollars, it is desirable to achieve compliance out of the box rather than having to implement it as a customer and then waste further funds into that. Given the market demand for GMP compliance readiness based on our core principles at the development stage, we at Miltenyi decided to tackle a different approach. We decided to develop our own operating system based on a long-term support Linux kernel. In fact, it allows for a cybersecurity advantage over Windows systems given the small market share on computers of roughly 4% compared to a 70% share for Windows. In addition, we can tailor and introduce only features required for the intended use of the instrument and avoid unnecessary OS access by offering all features through the data acquisition software and not the operating system by avoiding an operating system graphical user interface. Our MaxQuant analyzer family and the Taito cell sorter are the instruments in our cell analysis portfolio that are designed to safeguard data integrity and traceability by the principle I mentioned previously. We are offering read-only hardened non-commercial Linux operating system where data acquisition is physically separated from the operating system on a different drive. We have in both systems a powerful user managed system with up to 57 different rights options to segregate duties and configure roles according to the required intended use. Data audit trails and system audit trails have been implemented, as well as signed data reports and extensive system audit trails for full instrument history. Moreover, we offer high compliance service contracts where computer system validation services and consulting will be available in the near future. To give you an actual insight into our powerful user management system that you will find on our cell analysis portfolio instruments, to achieve compliance with the 21 CFR Part 11 add-on, you can see here screenshots of our user management system. As you see, it allows you to configure different audit trail management rights, rights of the private files of a user, rights of public access files for the user, or interface access, whether you have full access, you have administrator access, or you have access only to the express user that I will demonstrate you in the next slide. Also, we have a separate configuration for the user management itself. Besides these, you can configure password policies, you can import or export configurations if you have several instruments purchased from Miltenyi Biotec, and also, most importantly, you can connect to an LDAP of your own company, so you don't have to duplicate user settings on the instrument, but basically can import users from the LDAP server and use those on our instruments. Besides the very detailed user management system that allows you to configure custom roles and use preset roles to realize the segregation of duty as it is necessary on our instruments, we have also a special mode that is called the Express User and allows you to select and assign single protocols that you pre-configured as an administrator to users if necessary. Users can thereby easily load saved and validated instrument settings as well as analysis templates for their gating strategy. Users can perform the daily calibration of the instrument and basically just click and run the assay required. I would like to demonstrate to you an exemplary historian that you can export from our MaxQuant analyzer and Taito instruments to archive operator and system actions for transparent traceability. Our audit trail report answers the most important questions, which are when, who, did, on which instrument, what, and why. The detailed description field shows to you all critical experiment settings in this example. Moreover, files are recorded on the instrument and have an MD5 checksum calculated upon their creation to ensure in alignment with Alcoa principles that the file has not been altered, otherwise the checksum will obviously change. This is a very nice example of our technical measures to comply with data integrity requirements. Obviously, inspection readiness of quality control and process control instrumentation in a GMP setting is not limited only to Alcoa principles, data integrity, user management systems, segregation of duties, and so on. It is also important to reduce different sources of variation to standardize your results. And this is what I would like to talk about with you in the next slides, showing to you how Miltenyi Biotec tackles these challenges. What flow cytometry operators encounter day by day is inter-instrument fluorescence signal variation. If you run the same assay with the same sample and the same staining on 3 different flow cytometers, even if they are produced by the same manufacturer and are of the same model, you will notice fluorescence signal intensity variations. There are several factors that contribute to these results, mainly the physics of the instrument optical bench. Excitation light source can have different age and thereby produce variation in excitation light. The same is true for the fluorescence signal detectors, for example, PMTs on the emission side. Photo-optical elements age with time and lose their factory state abilities. Both, however, results in the need of increasing voltages or gains. In this example, you see that to achieve the same median fluorescence intensity, 2 different instruments will need slightly different gains of 400 or 430. So what is a possible solution to tackle this observation? At Miltenyi, we developed the so-called smart gains technology. What it basically means is that we use our MaxQuant calibration beads with a known fluorescence intensity to calibrate the instrument by characterizing the PMTs of each instrument. To do so, we create a PMT calibration curve measuring our beads, which gives the knowledge about what gains are necessary to achieve a certain fluorescence intensity at a certain emission wavelength in a certain channel. So what basically happens is that knowing the target fluorescence of your assay, an operator can use the same instrument setting for the instrument to identify automatically the necessary gains and adjust them accordingly. Thereby, our instruments allow for assay standardization and instrument optical aging and other non-assay related effects to not influence your assay results. By transferring the instrument settings, you enable each of your instruments to find the actual gain that is required for the fluorescence intensity. These slides nicely demonstrate the power of the smart gain technology. What you see here is basically an assay that has been carried out on several instruments from the same sample and the same staining of the sample. What we did is basically to transfer instrument settings from one instrument, which is called here the MQ master, to several other instruments. And what you see is basically that measuring the same assay with the same instrument settings on several other instruments results in the same fluorescence intensity histogram or profile of the assay in this example. If you look at the overlay, they are almost similar. This overlay shows the power of the smart gain technology and its standardization impact. Another aspect of variation in flow cytometry assay results I would like to talk about is manual gating. Manual gating is prone to differences and bias mainly determined by operator experience. However, even among experienced users, one will find slight variations in population statistics. What it means is that to exclude the human factor as a source of variability, it requires reliable and robust gating automation. At Miltenyi, we developed so-called express modes for gating automation at a push of a button. Express modes are fully automated acquisition and analysis max-quantify software features to standardize flow cytometry results and are application-specific and trained to identify target populations on multiple datasets of all regions. Express modes can be customized for your application and trained on your data to cover all use cases and eliminate operator bias. What you see on this slide is a typical express mode layout output with dot plots or histograms of your target populations on the left-hand side, with an associated statistics output of the results on the right-hand side, exportable in a GMP-compliant and archivable format. But what really enhances and enables the power of express modes actually? To explain to you all the benefits of our express modes that I just presented to you in a previous slide, I would like to talk about another source of variation. And this is reagents that you use in your everyday work in flow cytometry assays. So what the laboratory needs is consistent performance across reagent lots. Results for patients should be equivalent when measured with a current and a replacement lot of reagents. Whatever their cause is, lot-to-lot reagents inconsistencies can have significant effects on the results of tests performed in a lab. Let me show you the power of our dried-down reagents, the Stain Express, together bundled with our express modes. In simple words, Stain Express kits will help you to save time and reduce human errors. Stain Express are dried antibody cocktails and enable you to skip manual dilution steps and obtain reliable and consistent results. Stain Express dry antibody cocktails are pre-formulated multicolor panels dried onto the bottom of standard flow cytometry tubes and are barcoded, which allows you to automate the entry of sample details, data acquisition, and data analysis together with the MaxQuant Analyzer family instruments. When using a MaxQuant Analyzer, Stain Express kits can be integrated into a fully automated workflow solution utilizing, for example, the CAR T-cell Express Mode package. Utilizing the CAR T-cell Express Mode package gives you the benefit of predefined experiment settings, acquisition, and automated analysis, which are time-saving and error-preventing benefits to mention, as well as gating parameters that are automatically adjusted for each data file to identify your target populations reliably within your measurements. Thereby, the combination of Express Mode and Stain Express builds an ideal and reliable workflow without operator bias, enabling comparability and standardization for GMP QC assays. I hope you enjoyed the webinar so far and could learn how Miltenyi Biotec achieves inspection readiness for GMP QC use cases out of the box in our cell analysis portfolio by combining signal standardization features like the SmartGains technology with software features like the Express modes for automated data acquisition and automated data analysis. To round up our comparability efforts, we combine these technologies with standardized reagents like the Stain Express kits for a fully automated and standardized workflow. Our electronic documentation and user management system allow for the required segregation of duties to realize our core principles combined with a complete and archivable instrument historian. Don't hesitate to contact me if you have any further questions, and thank you again for listening and your attention.